Here we go. All right, this is Statistics Chapter 2. We haven't done a lot in Chapter 1. We probably should go over some of that stuff, but I figured, hey, we'll just get with Laura Lee and do this like this and like that, and y'all. No? Okay. So, what we got to do is we have to take all this information from this, right? This data group, okay? And from that data group, whoa, part of my book, well, can't have that. Part of my data group, right? I had to make sure I listed it, so I decided to use a stem and leaf plot. Even though in Chapter 2 they don't teach it, I was like, it's a really good way to organize your data. And so a stem and leaf plot starts like this, where you have a 40, 50, 60, 70, 80, 90, 100. So each class is 10. Does that make sense? So our class size, or our group size, is actually 10. Okay? So that answers one question. Okay? And so we go through and we go through all the data and we go like, okay, how many 40s? How many? Okay, there's two 45s, right? So there's two 45s, and there's a 46, and then there's a 59, and then there's a 59, and then a 63, a 64, a 65, a 65, a 66, and you get the picture, right? And so you write down all the data that you have, okay? And from that, you decide what type of shape do you have. And we notice that we have a shape. And what we call this is a bell curve. Now in your book it was called like a cluster something modal blah blah blah. I don't know. It's a crazy name. What do they call it? Anyways, I think it was in the first. Oh, there it is. They called it mound shape symmetrical. Okay, whatever. I call it bell shape. Now, the thing is later on, this is what we're going to be working with a lot. Is these bell shaped curves. Okay. Now think about this. If I take this and I turn it like this, it fits this curve, right? Kind of. It's kind of a high bell. It's weird. But it's still bell-shaped. Okay? Now it's not shaped like skewed to the left or to the right. Meaning it doesn't go like this and then go like that and then drop. Right? So it kind of has a little bit on both sides. Okay? So we're good to go. We got a nice bell curve. Okay. Now I want to know the range. Okay.
Miguel, Cruz, please come
the range
to the office. Miguel,
is
Cruz, please come to the room.
Pretty simple. The range goes from 45, or your first number, to your last number, right? But it's going to subtract the 45 from the last number, which is 109. 10 and 9, 109, right? So the range goes from 45 to 109. Okay? So there's two ways we can say this. We can say that it goes from 45 to 109, right? Or we can give or, the big V is or, right? Or we can give the actual number of the range, which is 64. Good. Okay, and so that is our range. Alright, so now check it out. Check it out. The next part is class size. And what class size is it takes the highest number and the lowest number and does what? Yeah, divides it by the group size, right? So our group sizes are 10, right? So our range is 64 divided by 10. So we get 6.4. And that is what our class size is. That's how you determine your class size. Okay? Now, if I want to determine relative frequency, they have to ask me, like, of what group. Okay? They could ask multiple groups if they wanted. They could say, well, from 50 to 60, what's your relative frequency? Right? So 50 and 60, 50 and in logic, we use this big dot as an and. So 50 and 60.
Colin, Andy, please come to the middle school office. Colin, Andy, to the middle school office. Thank you.
Implies, right? So this is then, and the double one is implies. So it implies what? It implies, well, 50 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10, right? Now, there's 10 numbers in 50 in 50s and in the 60s. Okay? So that is the number in the group 10. Right? But then what's the total number? So you go through and you add these all up. And we found that the total number was 70. Okay? That's a very important number to remember. When we deal with total number, we use that a lot. Okay? Relative frequency just matters on, well, it's relative to the group that you're talking about. Does that make sense? So in this case, the relative frequency is 10 over 70, which is 1/7. Okay? So that's how you would find relative frequency. If I were going to find it in the 80s, right, then I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26. So I'd have 26 over 70, and then I would break that down. So that's 13 over 35. And that's your relative frequency for the 80s. Okay? Now we're going to talk about Chapter 3 a little bit. Okay? So pause it and start it.